Hello everyone, this is Mr. Appel, and today I'm going to teach you about even versus odd functions. So you see here we've kind of defined what makes something even or odd or neither. Just to kind of summarize what's here, basically if f of negative x gives you the same thing as f of x, then f of x is even. In other words, if you replace x with the opposite of x, then it's even. So if you replace it with negative x, it's an even function. What that looks like graphically is it's going to be symmetric over the y-axis. So it's going to have y-axis symmetry. An odd function is one that if you replace x with the opposite of x, the negative of x, you get the negative of whatever that original function was. So you essentially get the opposite of that function. So if you're thinking about this in terms of numbers, for an even, if you had a function where, let's say, 2 gave you 8, then if you plugged in the opposite of 2, you'd get the same thing. You'd get 8. For an odd function, same thing. If you started with x equals 2, y equals 8, if you plugged in the opposite of 2, your answer would be, the output would be the opposite of 8. So that's what that would sort of look like numerically. Odd functions are symmetric over the origin, and that's kind of a tricky concept, but another way of thinking about that is it will have 180-degree rotational symmetry, and I'll show you what that looks like in just a second. And if neither of those things happen, it's neither even nor odd, so that's how that works. So let's look at some examples. I think it'll make more sense. So this first one, we've got f of x is 3x squared plus 4. So what I want to do is see what happens when I plug negative x in. So I'm just going to plug negative x in wherever I see an x, and then I'm going to simplify. And of course, negative x squared is negative x times negative x, which is positive x squared. So this just becomes 3x squared plus 4. Well, how does that compare to the original function? Well, it's equal to the original function. So f of negative x is equal to f of x. They're the same. That makes this an even function. Now, what does that look like on a graph? Right? You need to be able to do it algebraically, but you also need to be able to do it on a graph. So on a graph, what that looks like is here I'm taking a copy of that function, and I'm just going to flip it over the y-axis. So I'm going to flip it horizontally, and you see that when I do that, it's exactly the same. And you can see that without me having to do my smartboard flip, right? But it's got that y-axis symmetry. Okay. Now let's look at this next example. So in this example, again, I want to evaluate f of negative x and see what happens. So that's negative of negative x cubed plus negative x squared plus 20 times negative x. So negative x cubed, remember when you raise a negative to the third power, you get another negative, but then it's the negative of that, so that becomes positive x cubed. Negative x squared is positive x squared, and 20 times negative x is a minus 20x. So now how does this compare to the original function? Well, the first term is the opposite, but the second term is the same. And the third term is the opposite. So the only choices, if it's even, it would be exactly the same. It's not that. If it was odd, it would be the complete opposite of this. And it's not the complete opposite either because that x squared is the same. So this one is going to be neither or neither. But no, we're not going to call the whole thing off because we've got more work to do. Oh man, he's on a roll. Okay, I want you to see what this looks like graphically, though. Clearly, I think you can see it does not have y-axis symmetry here, right? It looks different on the left than it does on the y. Now, if you rotate it, this one is close, but watch what happens. If I rotate that thing 180 degrees, it does not match up exactly. And so, therefore, it's neither. And you can tell that by graphing. I wouldn't ask you to do one by graphing that kind of looked like it might work, like this one did, but just wanted you to see what that looked like. Okay, now this last one, x to the fifth minus x to the third. Again, I'm going to evaluate f of negative x. Well, negative x to the fifth is just negative x to the fifth, right? Because it's raised to an odd power, it stays negative, minus negative x to the third, which is going to be negative x to the third. So that's going to become negative x to the fifth plus x to the third. So what happened to f of negative x? It became the exact opposite of the original function, right? That went negative and that went positive. So that makes this an odd function. And graphically what that looks like right here is, again, it's got that symmetry about the origin, but the easier way to see it is if I do a 180-degree rotation about the origin, notice it falls right on top of itself. It's exactly the same. And that's how you can recognize an odd function when you see it. That's all for now. Thanks for watching.